Hello everyone, this is another video in which I am going to solve a problem that is the longest subarray with some key. So first let's read the problem statement. The problem statement is saying that we are given with an array nums of size n and an integer k. Find the length of the longest subarray that sums to k, and if no such subarray exists then we have to return 0. So what it is saying is we are given with an input array and along with a value k. That k is nothing but a sum which we want from a subarray. And our task is to find the longest like length of the longest subarray that sums to k. It means there can be the multiple subarrays possible in this entire input array, but we have to return the length of the longest subarray, which is giving that sum k. And if none of the subarray exists, then we have to return 0 in that case. This is the simple example which I have taken. The input array of size 6 and the k value is given as 15. Now we have to find the length of the longest subarray, which is giving this particular sum 15. So as I have just told, there can be multiple subarrays. We can see here two subarrays are possible which are giving this sum 15. One is this 10, 5, 15, and another one is this one 5, 2, 7, 1. This is a like subarray, a contiguous part in the array. So in this, the longest length is 4 in this case. So the output of this particular input will be 4. Now let's see that what is the simplest approach, the naive approach which we can follow in order to solve this problem. So first of all, what we can think is that okay, if I want the longest subarray, the length of the longest subarray, firstly I should know that what are the subarrays possible which are giving this particular sum k. And to do that, the simplest thing I can do that is I can just see for all the possibilities of subarrays which will be formed. So for that I can just go at every index and then check for all the possible subarrays which are starting from that particular index. Let's say if I am right now at 0th index, so from the 0 index, what are the possible subarrays like this 0 index itself, then from 0 to 1, then from 0 to 2, then from 0 to 3, then from 0 to 4, and then from 0 to 5, like this. If I am at right now at one index, then I can just start from one, just one subarray for 5, then 1 to 2, then 1 to 3, then 1 to 4, and then 1 to 5. Like this, I can find the possibilities of all the subarrays starting from every index and ending at different indices. So now this is one approach, but in this we can see is that the number of operations required in this particular approach will be more. But yes, for the implementation purpose and for the just have a basic understanding that how we can solve this, we will just see it. So it's like firstly I will be at 0 index and then I will be checking for all the particular subarrays possible from here. From 0, then 0 to 1, 0 to 2, like at then one, then at one index. So from for one itself, then 1 to 2, then 1 to 3, like this. And I will be just maintaining a particular variable in which I will be updating the length whenever I will be getting a subarray with that some key. Okay, so I will just update the length or the max length variable, whatever I will be maintaining. And whenever I get a subarray with the length which is greater than the previous length, then I will just update it, and at the end I will return it. So this is the all logic about the naive approach. Now let's get into the implementation part to see how we can write it. Okay, and then we will just go that how we can optimize that further. This is the editor where I will be writing the code. So let's just firstly take the size of this nums array. So side n, that is nums dot size, and after taking the size, what we have to do is we will have to maintain a max length variable in which we will be updating the maximum length we will be seeing so far. So initially I have initialized this with 0, and for this I will have to basically use the two loops. One is the loop for iterating through the indices for every time, like going at the new index in order to have the possible subarrays, and then for that particular index I will have to run another loop so that I can iterate for the entire subarray. I can iterate through the entire array in order to have the possibilities of all subarrays. So for example, if right now I am at 0 index, let's say I equal to 0. So right now I am 0 index. Now for this 0, I will have to check all the subarrays like 0, then 0 to 1, then 0 to 2. So for that I will have to run another loop. So for that I will be using another loop. Firstly, int I equal to 0, I less than n, and I plus plus. Now in this I will be running another loop for int j. Now this particular j will be started from where the I is started. Let's say I is at 0, then j will be starting from 0. So for 0, then 0 to 1, then 0 to, then 0 to 3, like this. And then if I is at 1, then we will be starting from 1 itself. For 1, then 1 to 2, then 1 to 3, like this. So this is j equal to I and j less than n, and then j plus plus. So this is how we will be doing. So if right now I am at I equal to 0 index, then I have to take the sum for every possible subarray. So we can also do one thing, then that we can also take another loop. Like if I is equal to 0 and then j equal to I, so I can just go for another loop in order to have that specific subarray and then have the sum and check if it is equal to k or not. But that is obviously it is taking more number of operations than this. So we can also do that same thing with the help of two loops as well. How we can do is that if I is at 0 index, and then I will be starting for j from I itself. So if I is equal to 0, then I will be starting from j equal to I itself, that is j equal to 0. Now as the j moves ahead, we simultaneously take the sum inside of that particular nums of j value. We can take that inside the sum, and parallelly we can just check if that sum is equal to k or not. We check that okay, the sum is equal to k, so we can just update that particular in the max length. This is we can just do with the help of two loops itself. So now we will have to just maintain a sum variable here, that is sum equal to 0, and here we can just take that nums of j inside this sum, sums of j, and as we have taken this sum, now parallelly like firstly for j equal to 0, this is one subarray, then we will take its sum and check if it is equal to k, and if it is not, okay, then we will move this particular j ahead, and then we are having another possibility of this subarray, so we will again check this particular sum. Same thing we will be doing with the next, again we will be taking the sum, and this is another possible subarray, so we will again check its sum. So parallelly we are doing this, we need not to take the three loops. Okay, so this is how we will do, and just check if this sum is equal to k or not. So if this sum is equal to k, then we can just update the length in the max length with the help of this comparing with the previous max length. And see, now if this particular I is right now at here, let's say this particular I is here at this one index, and later on when we are starting from this I itself, then j move at this particular index. So now we got that okay, this particular subarray is giving me the length 15, sorry, the sum 15. So therefore I will have to update its length. Now what will be the formula in that case? Like 4 minus 1, that will be 3, plus 1 we will have to do, that is j minus I plus 1, that will be giving the complete length. So j minus I plus 1 is going to give me the length, and that is going in the max length if it is maximum. This is how we have to do, and we need not to do anything if like sum goes beyond k or something, whatever it happens, we need not to worry about it. Anytime if we get to know that okay, this particular sum is giving is basically equal to k, so we can just update that length, and we only want that particular. So we can at the end just return this max length. Let's just take an input here. Let's say the size is 6, and what are the values? 10, 5, 2, 7, 1, 9. 10, 5, 2, 7, 1, 9. And what is the sum we are checking for? That is for 50. Let's just run it, how it works. It will be giving this length 5271. This is a maximum length of the subarray, which is giving the sum key. Okay, so this is the longest subarray with sum 15, which is of length 4, which we have seen. So this is the output in this case. Okay, so right now we have just seen the brute force approach for this particular problem, and here we can see that we are using the two loops. Okay, so that is like from for I equal to 0, this loop will be running from 0 to n minus 1. It is a kind of n times. Then from I equal to 1, for I equal to 1, it will be running from 1 to n minus 1, like n minus 1 time. And similarly, if we see that for I equal to n minus 1, it will be running only for one time. So it's kind of a formula we can see n into n plus 1 by 2, which is just taking n square operations in order to solve this particular problem. So this is because we are recomputing the sum again and again for every possible subarray. Okay. So because of this recomputation, it is taking big O of n square time complexity. Now we can reduce this by doing something that, see, what we are doing in this brute force. We are just recomputing that sum again and again, and we are checking explicitly for all the possible subarrays, uh, by which we end up getting the n square kind of operations. We can do something in which we can just take on the sum again, like the sum one by one for every value in this particular input array, and we need not to go back to a particular index in order to recompute that sum. So this is something we can do. Now let's see this particular approach, that how we can use that in order to minimize this particular time complexity. What we can do is, see, if I am having this kind of array, a particular, okay, from 0 to a particular index, what I can do is I can just start from the 0th index and then go at a last index, and one by one I will be taking the cumulative sum, a kind of cumulative sum. Means one sum I have taken from the 0th index, then adding the first index element, then adding second index element, like this. This is called a cumulative sum. We can also call it as a prefix sum. means accumulating the particular sum from the starting indexes till the current index, that is known as a prefix sum. So the intuition behind is that at whatever current index I am right now, I am having all the possibilities of subarrays which are ending at this particular index. Okay, I am not talking about any of the like all the subarrays in the input array. I am just saying that right now I am present at whatever index I am present right now. I am having all the possibilities of those subarrays. For example, I am currently at this index. For example, I am currently at this index and I am saying that okay, right now I am having one prefix sum in my hand. So this I can say it as prefix sum, and it can be anything. Oh, I have just taken the example. This is the prefix sum right now. Now I am saying that if I am standing at fourth index, then I am having all the possibilities of subarrays. What are the possibilities? Like the subarray from 0 to 4, then from 1 to 4, then from 2 to 4, then from 3 to 4, then only 4. These all are the possibilities I am only having. I am having control on these subarrays itself. I am not talking about any of the subarray beyond this particular index. So now if I am having the control on these subarrays itself, I am just saying, just I am assuming, I am not saying it is a final one. I am just assuming that maybe this is a subarray with that sum k which I needed. Okay, because if I will be finding any of the subarray which are ending at this particular index, so those will be something from here itself only. And just I am assuming that if this is a subarray which is having that particular sum key, okay, let's give it as sum key, the subarray which is having the sum key. Now for sure, this particular part this particular part will be having that prefix sum minus k, because from 0 to this current index I am having the prefix sum in my hand. And if I'm just assuming that this is a subarray which I will be getting with the sum key, if this is here, then for sure this particular part will be prefix sum minus k. And now if I said in this way that I'm just assuming that this is a subarray with sum k, I can also say in a reverse way. I can say that if this is the if this is the prefix sum I got at this particular index, then if I will be able to find the prefix sum minus k in the past, then I can see that till whatever index that particular prefix sum minus k was available, from that index plus 1 means from this second index till this current index, that will be the subarray with the sum key. And that is the kind of reverse engineering I will be following here. So this, let's say this is a particular j index at which I am right now, and let's say this is a index I. So if I am getting any particular prefix sum in the past where I have encountered this prefix sum minus key, okay, from that I plus 1 index from here to here, this will be the subarray with the sum key. This is the whole logic behind it, and this is the core idea which I have to talk about. So now we have seen this. Now let's talk about this particular same example. Let's perform a simple dry run on this in order to understand it more. This is a simple input example, the array of size 6 I have taken, and the key value which is given, that is 15 for the subarray which we now, according to the intuition which we just seen, let's say I is the index which is pointing at the 0th index. Now I will have to keep one prefix sum here. Okay, this is the prefix sum which I have initialized to 0 now, and I will also be maintaining a max length variable in which I will be updating the maximum length of the subarray which I will be encountering. These two I have taken, and now we have seen that we have to basically get the length of the longest subarray. So for that we are also taking the prefix sums and all. So in order to store these, we will need some data structure, that is hash map we will be using. Okay, that is a hashing approach we will be using. So in that we will be storing the prefix sum at every index, and also with that at what particular index that prefix sum is coming, that also we have to store. So for that we will be using the map, that is specifically if I say, then I will be using the unordered map. We can also use map because see, uh, we can also use the map, but we will not be using because we do not require any ordering here. Okay, we just want to check the existence of something in the map, so we can just use unordered map. And also it is providing the fast lookup and insertion and all, just having the constant operations that we will see later, that what is the time complexity, this complexity will be required. So for that, let me just take a map here. This is, I can just this as map, and now right now I am at this index 0. If at index 0 I am seeing the 10, so first it will be coming in the prefix sum, so it will become 10. And now I will be checking for what? I will be checking for prefix sum minus k, as I have just explained. So what is prefix sum minus k? That is 10 minus 15 minus 5. Have we seen in the map? No, we have not seen. So we will not be doing anything. Just whatever the prefix sum came, at what index it came, just store inside the map. So what we have seen here, that prefix sum we have seen, and at what index we have seen at 0. So this we have just put here. Now I will be moved ahead. When I moved ahead, it's C5. So 5 will be added inside the prefix sum. So when 5 is added, it will become 15. Again, we have to check in the map for prefix sum minus k. So prefix sum minus k is 15 minus 15, 0. Have we seen 0 in the map? Now here is the important concept which we have to understand here. See, we are saying that 15 minus 15, 0. We have not seen so far in the map. So should we miss this particular subarray? Because we can see this is a valid subarray and we cannot miss it. So the important concept here is that initially what was the prefix sum when we have not yet started taking the cumulative sum? That was initially 0. That is a kind of virtual prefix sum, we can say. Okay, so initially that particular prefix sum was 0 when we have not taken any of the values inside this. So it was initially 0, and at what index we were right at that point of time? We have not started with any index, so therefore we can say that it was at -1 index. So it was at -1 index. So now this is the important catch here, that we will have to, before storing anything inside the map, we firstly have to store this thing, that firstly the virtual prefix sum was 0 and that was at -1 index, so that we cannot miss any of the subarrays which are starting from the 0th index. You can just uh, have a understanding with the separate example or different example which is having a particular valid subarray which is starting from 0 index. We have to make sure that we are inserting this particular prefix sum, virtual prefix sum, along with that -1 index in the map, so that we cannot miss any valid subarray. Therefore now if we check if 15 minus 15, 0 exists, yes, it exists. And at what index? At -1 index. Therefore, what will be the formula for getting the maximum length? Right now I am at 1 index. For length, right now I am at one index. 1 minus at what that particular prefix sum minus k was available, that was available at -1 index here last time. Now this is not something we are adding an extra thing into it, that we are inserting this 0 comma -1. It is just based on the logic we are doing, that if we are saying that 15 minus 15, have we encountered 0? So yes, we have encountered where when we have not yet started with taking the sum. So that at that point of time the virtual prefix sum was 0, and that too was at -1 index. Now 1 minus 1 will be minus plus, and this will be 2, and that is basically giving me the valid length, that is this 2 length subarray we have encountered here. So this length now came as 2. We will see its formula, like I minus what will be done, like how we can get that particular index with the help of map. This is the 2 length we have seen so far. Now let's firstly check that, okay, we have to insert this particular prefix sum. So prefix sum was 15 at this point, and we will be inserting it at what index it is? It is at index 1. We have also inserted this in the prefix sum. Now I will move ahead and check for another values. This 2 now, so this sum will become 17. And now again we will check for prefix sum minus k. So 17 minus 15, 2. It is not available in the map, so we will just insert this prefix sum inside the map. So it is like 17, and what is the index? Index is 2. We have stored it. Now I will move ahead for the another index, and now see 7. So prefix sum will become 17 plus 7, that is 24. Now 24 minus 15, 9 we have not seen in the map. Therefore, we will be just taking this prefix sum 24, and at what index we have seen it? We have seen it at 3rd index. So this is just stored inside the map. Now let's move to the another index, that is I will be moving at 4th index, and it will be seeing if 1 is here. Let's just add in the 1 here. So it will become 25. Now 25, the prefix sum is 25 minus 15, prefix sum minus k, that is 10. Have we seen in the map before? Yes, we have seen at this point, and that was at 0 index. So we have, because we have seen this prefix sum at 0 index, it means what? We are accumulating this particular prefix sum 0th index itself, and right now this prefix sum is 25. And if I have seen 10 before at any particular, like in the past in the map, then for sure at whatever index that's 10 prefix sum came, from that index plus 1, means from this index 1 index till this 4 index, is the subarray with that sum k. We can also see it in different way, that right now if I'm having the prefix sum 25, and I have seen 10 till 0 index at the map, as the map is saying. So something has been happened from that +1 index till this current index, that it became the sum 15, so that it became 25, 10 plus 15, 20. So from that I plus 1, from that index what the map is giving, from that +1 means 1 index till this 4, this is the length. How will be the length calculated? Now length will be, right now we are at 4th index, so 4 minus what will be the index, because it was encountered at 0, so 4 minus 0, that will be giving us the length, and that is the valid length, that is 4. Now the it is maximum, so it will be 4 now. This is the maximum, and this is the sum also we got, so we'll also have to put inside the map, that is 25, and we have seen this at 4th index, so it will be stored inside the map. Now I will be moving ahead and it will see 9, so now when 9 is added, and it will become 34. So now have we seen 34 minus 15, that is 19, have we seen in the map? We have not seen in the map, so therefore we will just adding inside the this map, that is 34, and at index 5 we have seen this is added, and now I will move ahead and it will see array is completed, so this loop will be end. So this is how we have to do, and we can see that we are having the maximum length, the longest length of the subarray, which is the sum key, that is present, that length is present inside the max length, and we will just return it at the end. So now let's just see this in the implementation part, and whatever we come across, then we will also see. This is the firstly size of the nums, which size. Then what we have to use is unordered map. I have already explained we have to use unordered map. In this we will be taking the two parameters, one is for the prefix sum and another one is for putting the index where the prefix sum. So let's say this is the map of, this is the name of this map, and also one thing I have just explained, that we have to insert this map of 0 or the -1 index for this particular prefix, in order to avoid the missing of the valid subarrays which will be starting from 0 index, that is map of 0 equal to -1, as we have seen. And now we will be maintaining a prefix, that is sum, and initially initializing it with 0, and also maintaining a max length variable, initialized with 0 right now. And now I will be running a loop for int I equal to 0 less than n I plus plus. And now what we have to do is firstly take the prefix sum. Just add these values like a kind of cumulative sum. So prefix sum equal to nums of I, and once this prefix sum is taken, now what we have to check? We have to check for prefix sum minus k in the map, if it was encountered earlier or not. If, just put a condition if, and check inside the map with the help of find function, that if we have find this prefix sum minus k, this will be written in this way, like map.end. So what does this mean? That if we have find the prefix sum minus k earlier, so it will this particular iterator will not be pointing at the end for sure, and that will not be equal to end, so it will be true, condition will be true. And in that case, if we have seen, then max length will become the maximum of the previous max length, comma, what is the formula which we have that is I minus the current index, I minus what, I minus the previous index where we have encountered that particular prefix sum minus k. How we have to get, how we will be getting that? That is map of the prefix sum minus k, means inside the map where that prefix sum minus k was encountered, like this 10 comma 0, so that map of prefix sum minus k will be giving us that index. This will be like map of prefix sum minus k, this will be giving us the length, oh sorry, that the index where we have encountered, so I minus that index will be giving us the length. And now we have got the max length, and we can now just what we will be doing is, in the map, whatever that prefix sum is, we will be just adding that with its index. This is the thing we have to do here, is after just taking the max length, if it is we have found, then we can just take this prefix sum and along with that index just keep it inside the map. This is the simple thing which we have to do, and at the end we will just return this max length. Now just let me remove this output and run this for this particular implementation. So again it will be giving the maximum length 4, the longest subarray, the length 4. Yes, we are seeing that the longest subarray with sum 15 is of length 4. Okay, so we have seen this particular approach as well, but here is a problem in this particular line, that if we are only having the positive elements, then in that case this will work fine, because at every point of time, at every index, this particular sum is going to increase. It is not going to remain the same or something. It is always going to increase. Therefore this line is perfect in that case, that we will be updating the index for every prefix sum in the map. But this particular line becomes a problem when there are zeros and the negatives also present in the input. In that case, the prefix sum might be repeated, and for that repeated prefix sum, we are just re-updating that particular index. Okay, and in that case, because we have updated the latest index for that particular repeated prefix sum, so we are not going to get the longest subarray. That will be giving us the smallest subarray. Okay. So this is the problem. For example, the same example I am taking here. Let's say after 10, this 0 is present here, then 5, then 2, then 7, then 1, let's say -1, then again 1. For example, so whatever we have seen, whatever the process we have just seen here, that same process if we are applying here, then firstly for the 10, the index will be 0. And when the sum is repeated here, also with 10, then the index will be re-updated. That index will now become 1. So it means at in future, at any point of time, if we are asking for 10, if we are seeing for 10 in the map, then it will be shown with the latest index, that is 1 index, because of which it will be giving us the smallest subarray, not the longest subarray. So here we have to just keep in mind that whenever we are having the negative elements or the zeros, in that case we have to keep uh, we have to make sure that whenever we write this, and whenever we go to update the prefix sum, firstly check if it is already present in the map or not. If it is not present, then you update it, then you can update. But if it is already present, then we cannot re-update that particular index, because it is not going to give us the longest subarray with that sum key. So we will have to keep one check here, that if this map dot find, and we will keep a check if this prefix sum is not there, then only we will be adding that prefix sum with that index. What does this mean? We are checking for the prefix sum, and if it is not present, it means it will be pointing towards the end position. Okay, and that will be equal to this end, so the condition will become true. And now you can just write that same line which we have written there, that map of prefix sum, that map of prefix, and the corresponding index with that we can add here. And if it is already present, then it will be obviously presenting pointing at particular index or a position, sorry. That will not be equal to end, so it will be just false, and you will not be re-updating that particular end. So this is the simple thing I have to mention here, means the just a differentiating between the positives, and input array consists of the positives, and if the input array is also consisting of the positives, negatives, and zeros all, so in that case it works. And this is basically a generalized, I can say, a condition which we can write for all the positives, negatives, and zeros. So this we have seen. Now here we can see that only one loop is used. Okay, so this is because it is taking the n number of operations, and also for this n number of operations, whenever one element goes inside the map, in that case it is just taking the constant operation, because we are using the unordered map. If we were using the map, then it will be just taking the log n operations for the lookup and insertion and all. But unordered map is just takes the constant operations. Just in the worst case, if it happens that multiple collisions happen, if all the number of elements, multiple elements are going inside the same bucket, then in that case it might become n square. In the worst case, that is very rare, but yes, it is taking big O of n in the average case. Okay, so in this particular approach, we have seen the logic, the implementation part, the time complexity and space complexity, and also we have seen the different cases in which like the input constraints are like for the positives or also for the negatives and zeros. So we can see here that in this particular approach, this is a optimal one, which is for the all the positives, negatives, and zeros if the input array consists. So we cannot go beyond this particular approach, because it is the kind of optimal one if the particular array consists of the negative values as well. Okay. But in case if the input constraints are such that it is saying that the non-negative values are only allowed, it means the only the positives and zeros are allowed, then in that case we can move towards more optimized approach, and that is the kind of space optimization technique we can say, not a generalized optimal one, because it is only valid for the input constraints with the non-negative values like positives and zeros. Okay, so now the another technique is the two pointer technique, or we also call it as a sliding window approach, and that is used basically when the negative non-negative values are only allowed, means the positives and zeros are only allowed. So this is the important constraint here, that the sliding window only used for the positives and zeros, not for the negatives, because in that case it fails. And let's just see that how it works. So if we are given with a particular input array which is consisting only of the positives and zeros, then in that case we can just form a particular window. We can just maintain a window, and in that window, let me just explain how it works. Firstly, we maintain a zero, sorry, the sum, and in that sum we just keep on adding the elements from the left pointer, sorry, from the right pointer, and we just check for the three things. Firstly, we check if the sum is going beyond k. If the sum is going beyond k, then we just shrink that particular window from the left, okay, just to decrease that particular sum, and we just keep on decreasing that sum until that sum becomes less than or equal to k. And one another thing is that if the sum is less than k, then in that case we just have to keep on adding from the right pointer and expand that window. And at any point of time, if we come across that if the sum is equal to k, then we can just update our answer, our max length variable, with that particular length. Okay, if that subarray is giving that sum k. So only the three things are required to check for the sum, the status of sum, that if it is less than, then just keep on from the right pointer. If it is less than k, sorry, if it is greater than k, then just shrink it from the left by decreasing the sum until the sum is getting less than or equal to k. And if the sum is equal to k, then that is something which we needed, and we can just update its length. So this is all we have to do in the sliding window. But one thing we can think of, that okay, what if the sliding this particular window gets empty? Window gets empty means if the j moves ahead of, if the I moves ahead of j. So it's like if this particular I goes beyond j, then in that case this particular window will be empty, and that will be basically a invalid window size. So being the window being empty is not the problem, but if we are processing on that particular window, means on that particular indexes, like accessing something or performing any, then that is going to be the incorrect thing. So window might be invalid in this particular approach, but we do not have to perform any operations or access any particular indexes in that case. Whenever the window gets empty, whenever the I crosses j, firstly the window is rebuilt with the help of j pointer, because that is only expanding that window. Okay, so firstly this window is rebuilt, then only we take the sum from that right pointer, and then keep on checking for the status of the sum again, like if it is going beyond k or it is equal to k or whatever it is. Okay, so firstly the window is rebuilt, then only we perform the operation. So this is all about the window itself. If the window is getting empty or if the window is invalid, then we are not going to do anything. So this is the whole thing about this. The simple thing that the sum will be increased as the window expands with the help of j pointer, and the sum will be decreased when the window shrinks from the left pointer. This is all about it. Now let's just also have a dry run on this simple example. So firstly, this I will be pointing at here at this zero index, and j will be also pointing at this zero index. Both I and j pointer, the left pointer and the right pointer. Now we will be maintaining a prefix. Sorry, I will be just saying it is a prefix sum or a sum, and I can just the max length variable also, the maximum. Now in this sum, it will be just increasing the sum with the help of this right pointer, that is j pointer. Firstly, the 10 is there, so 10 will be coming in this sum. 10 is added in this. Now let's check. The k value is again that is equal to 15. You have to check for, and now it is less than 15. Therefore, we must add something. K will be moving ahead, and it will be adding 5 to this sum. And when this 5 is added, it becomes 15. And now it checks with the k, so it is equal to the k. So therefore, we will have to update its length. So how will be it's updated? The formula, get the length, 1 minus 0, that will be 1, but we will have to do plus 1 in order to get the complete length. So k minus I plus 1, that will be giving the length. So for now the length is 2. Now again move j ahead in order to add something more. Now 2 is added and it becomes 17. Now it becomes 17, and it is greater than this k, so therefore we must decrease something. The something that will be decreased from the left pointer. 10 will be decreased here. Minus 10 will be done and it will become 7. And then this left pointer will be moved. Right now the window is this much only. Then it again checks that okay, now the sum is less than k. So therefore I must add something in it. This j will be moved ahead and it will add something that will now become 14. And now the sum is still less than sum. Sorry, the sum is less than still less than k. Therefore some more to be added. J will be moving ahead and it will now do +1 which will make sum as 15. Now it is again equal to k. So therefore we must have the length j minus I plus 1, 4 minus 1, 3 plus 1, 4. J minus I plus 1, that will be giving us the another maximum length, that is 4. Now j will be again moving ahead. It will now be 9. When it will be added in this, that will become 24. And now it became 24, but it is greater than k. So therefore we must decrease something. So this 5 will be decreased. What it will become? It will become 19. It will become 19. Okay? Then I, this left pointer I will be moving ahead. Now it is greater than k, so it will again decrease something. So now it will become 17, and this I will be moving ahead again. Again this is greater than k, so it will again decrease something. So that 7 will be decreased and it will become 10 now. And again this left pointer will be decreased. And now the sum became less than k, so it has to be added something. When this j moves ahead, okay, so as soon as this j moves out of the indexes, out of the array, then we need not to check more because the window is not valid now. Okay, window is not maintained now. We have to just stop in that case, and we can see here that the max length is the length of the longest subarray. Okay, so this is the length and this returning at the end. Okay, so this is the particular approach we have seen for the sliding window, and let's get to the implementation part, that how we can implement it. Here I will firstly taking the size of this nums, that is nums.size, and now I will be maintaining a sum variable which size with 0, and I will be also maintaining a max length variable. That max length variable is now initialized with 0. Now I will be maintaining the 2 pointers, that is firstly for the left pointer and one is for the j pointer. So in this, firstly I will be running a while loop. In this while loop, what I have said is that we will be running this loop until j is less than n. It means the moment we go beyond the indexes or the input array, or any invalid index comes, then we will be just stopping that case. When this j is less than n, till that point only we will be running this particular loop. So in this, we will be just taking the sum of this nums of j inside the sum, and every point we will be just checking that if this sum is greater than k or not. Now if this sum is greater than k, then we will have to just decrement it from the left pointer until it becomes less than k or equal to k. We will just run a while loop here in which we will be performing this operation till this sum is greater than till this sum is greater than k. So in this case, I will be just taking this sum and decrementing it with the help of I pointer, that is a left pointer, and whenever it is decreased, I will be just incrementing that left pointer ahead. So once it is done, it means the sum becomes less than k or equal to k, and we will just keep a small check if this sum is equal to k, and if this is true, then we will be submitting this maximum length, means the max of max length, comma, how will we be finding the index, that is with the help of j minus I plus 1. And once this is done, we will also be incrementing this j. Now, one important thing I have to mention is, as I have already explained earlier, that if this particular window becomes empty, then what happens? So after this, we have to just return max length. Okay, and let's firstly check here. Then we going for the empty window case. The output of this will be 4. The length will be 4. The longest the longest subarray length is 4 for the sum equal to k. Now we are not explicitly making any check for the empty window, or if I crosses j. Okay, the empty window means if the I crosses j. So we are not explicitly giving that particular expression because we are not going to perform any of the operation whenever the window is getting empty. You can see here. Okay, so let me just take an example for it. So this is the example I have taken, and I'm just seeing that okay, right now let this I pointer and this j pointer be at 0 index, which are pointing here, and now I will be taking the just the sum and the maximum length. This sum is right now equal to 0, and this max length is also equal to 0. Now let's start from the like adding the sum from the right pointer. Firstly, j is pointing at 5, so this particular sum will become 5. And what I need is I have to get the subarrays with the sum 3. This is the case. I have the sum is right now 5, and we can see that this sum is greater than k. So it means we will have to decrement something from the left pointer. This left pointer is pointing at this 5 itself. And now if something is decreased, so now this particular sum will become 0. Okay, and as soon as the sum becomes 0, this I will be moving ahead because it has already decreased, and now this particular left pointer will be moving ahead according to the algorithm. When it is moved ahead, we can see that I crossed j. It means the window is no more a valid window. The window became empty. So are we doing any operation on this particular valid window? So we can see here that firstly sum was 0, max length was 0, and we have initialized this I and j were pointing at the 0 index. Then we came inside this particular loop, and we have taken the sum, that sum became as 5. Then we have checked here that sum became greater than k, so we have just decremented the sum, and I was moved ahead, so I now moved at this 1 index. Now we have seen that okay, sum is not equal to k, so therefore we will be not doing anything. Now what we are doing is we are just incrementing this particular j ahead. And what does this mean? We are basically rebuilding this particular window before performing any of the operation on this particular invalid window. Okay, so window being invalid is not the problem, but performing any operation on that invalid window is the problem. We are not doing actually in our algorithm. This firstly we are incrementing this j, means we are rebuilding that particular window, then only we are performing any of the operation. So firstly j is rebuilt, then we have checked the condition, okay, it is inside the index, so we will then be taking the sum of that particular valid window from I to j at 1 index. This is a valid window right now, and then we will be taking the sum and then checking for all those status of the sum and all. So this is how the empty window case is handled here. Okay. uh, yes, we have already seen the implementation part complete. Okay. So we have seen the implementation part of it, and now the space time complexity we can see here is that it is running in the linear time. The space complexity is obviously constant, and that is what we can say it as a space optimization technique, we call it. We cannot say it as a generalized optimal solution because it is only correct in the case of the constraints where only non-negative values are allowed. Okay, if the positives and zeros are only available, then only the sliding window approach, or we call it as a two-pointer technique, it can be used. Okay. Otherwise, if we are only having the negative values, like sorry, the positives, negatives, and zeros, all we are having, then in that case we can have the most optimal solution as the prefix sum plus the hashing approach. So we have seen this particular problem. It's like this particular different approaches of this particular problem, the different cases we have also the time complexity and space complexity of all the approaches we have seen. So now there are multiple variants, other variants of this particular problem as well, and that I will be covering in the upcoming videos. Till then, just keep learning and keep